Welcome to Saxon Math, Course 3, Lesson 98, Relationships and Functions. So today we're going to be talking about mainly relations and functions. Functions are a subset of relations, meaning that functions are always relations, but a relation is not always a function. We're going to talk about what relations are, what functions are, and how to figure out if a relation is a function. Now, a relation is just a pair of two sets of information. Relationships can be described in set notation, with a table, or as an equation or a graph. A relation always has a domain and a range. Now, a domain are your input values. It's what you're putting into the relation. The range is your output values. When we're talking about science, the domain will be our independent variable, and the range will be our dependent variable. If we're talking about a graph, the domain is our x value. We would always want to remember, domain is our x value. Our range is our y value. It's important. Now, a function is a relation where every input value has only one output value. That means if I have an input of 5, it has to give me the same output every time. If I have more than one outputs for the same input, it's not a function. That's one of our tests. Now, we can test that on a graph using something called the vertical line test. Since we said that our input is our x value, if there is any point on a graph where a vertical line, one going up and down, passes through two or more points, then the graph is not a function. Let's talk about why that's true. If there are 2 points on a vertical line, that means one x value, one domain, one input, has 2 y values, 2 outputs, 2 measurements in the range. Since we have only one output for every input in a function, if there are 2 outputs for an input, it is not a function. So a vertical line test is a test where you have to test every space, and if any of them make it not true, it is not a function. I'm going to show you how to do this in example 1. Now, example 1 says which of these graphs are not of relations are functions. So I'm going to take a straight edge, and we're going to put it across letter A. Now, as I'm moving across here, there's only one point on the line where it's touching. Here, there's only one point, there's only one point, there's only one point, and there's only one point. At no point on this line does a vertical line cross more than one point. Since a vertical line only ever crosses one point, A is a function. Now let's check B. B looks a little bit weird. It's not a straight line. Relations and functions don't always have to be a straight line. Let's test this out. Now here it's at one point, and it's at one point, and it's at one point, and it's at one point the entire time, meaning B is also a function. Now let's check C. C, we start off, here we're at one point, here we're at one point, here we're at 2 points, and 3 points, and 3 points, and 3 points. So this here, since there are so many points where we pass through the line more than once, this is not a function. These two are. Now notice, a function does not have to be a linear expression or equation. We don't have to be a straight line. You can have a curved function. What's important is that it does not go back over itself. If it goes back over itself, it is not a function. All right. Example 2 tells you to sketch a circle on a coordinate plane with the center on the origin and a radius of 5. Now, you'll need a graph in order to draw this. Now, if we go around and we draw this out, I've drawn a few marks where radius 5 would be. so I can get a decent circle. I started off with the 4 points on the axis. When you're drawing a circle, you want to start off with the 4 points on the axis most often. Now, since it has a distance of 5, this here is 5. This is 5. And the same is true for the other two as well. So that means this point, which is on our circle, is the point 5, 0. So let's write 5, 0. This point is 0, 5. This point is negative 5, 0. And this point is 0, negative 5. Now, as we're going through, it's asked us to find 4 points of pair, or 4 pairs of points in the relation, and then say, is the relation a function? Now, there's 2 tests that we have. We can look at the table of values, and we can look at the graph and do the vertical line test. If we look at the table of values, I want to point out that these 2 lines in our table of values have the same domain, 0, but different range. This means it is not a function. And if I grab my straight edge, if we go to those 2 points, you can see that those 2 points are places where the function or the relation would fail the vertical line test, because these 2 are on one vertical line. They're on one vertical line because they have the same input. Now notice these 2 points here have the same output of 0, but having the same output with different inputs would be on a horizontal line, not a vertical line. So we don't need to worry about seeing that. You only need to check if the domain is the same. If the domain is the same, then that's when you need to start making sure that the range is also the same. Now, example 3 gives us a graph of a student who went around and he had a timer for the time before school started, and in addition to his timer, he also counted the number of students who were at school. So, we've graphed that here. If there were 4 minutes before school, he saw there were 50 students. Here we have 4 and 50. If there were 10 minutes before school, he found there were 20 students. If there were 12 minutes before school, he found there were 12 students. If there were 10 minutes before school, he found 25 students. If there were 6 minutes before school, he found 40 students. And if there were 4 minutes before school, he found 60 students. Now, the relation that's represented here is not a function, but we can make a prediction based on a best fit line, like what I've drawn here. Notice this best fit line has points. This is the line which is closest to all of the points, and we can use the best fit line to make predictions on how many students he would see if there were a certain number of minutes left before school, which is what this question is asking us to do. It says, according to the graph, how many students would be expected 10 minutes before school? Now, 10 minutes before school is right here, at this point. So what we do is, if you have a piece of paper or a straight edge of your own, we'd go up to where the line meets at 10 minutes, and we're going to draw a little dashed line here, and a dashed line here. Now, the point on our line here is in between 20 and 25. We might say that he would expect 23 students. What about 8 minutes before school? At 8 minutes before school, If we use our straight edge again, we're closer to about 34 students. So you can see here that we can use our best fit line to make predictions. And that's how you do that. All right, this has been lesson 98, functions, relations. Notice that even if you have a non-function relation, you can make a best fit line, which is a function, and use that to make predictions. All right, have a wonderful day. Stay safe, wash your hands, and do your homework.